So it's related to the estimation. So what does estimation actually means? Let me explain to you with an example over here. Okay, so if we consider that we want to know, we want to actually estimate the result for the 12th class itself, and I say that the result would be 95%. The result would be 95%. So that's an estimate that I'm having related to the result over here. So it may be right or it may be wrong. So this is said to be what? This is said to be the point estimate. And further, we are also having another type that is related to interval estimate. We are having another type of the estimate that is related to the interval estimate, where we will be giving a estimate interval, where we will be having an estimate interval. Let us take the case that we are having interval from 93% to 97%. We are considering an interval from 93% to 97%, and further in this case particularly we are estimating that the result of 12th class will fall under this particular interval. It will fall under this particular interval. So actually what happens, we are having a sample and different entities that we selected from the population itself. So it is related to what? We are having the sample itself, and further the different data related to sample, it is said to be what? It is said to be the statistics. Okay, so these are basically related to the mean, that is represented by x bar, or it may be related to the standard error of the mean, that is standard error of the sample, that is represented by sigma x bar. So these can be the estimators. Using which we want to estimate the population parameters. So let us take the case that if I'm having 100, if I'm having population of 100, and further out of these 100 of the population, I selected the sample of 10 persons over here, and further I want to make a estimate related that the mean would be, particularly a mean of the population would be equal to 12, whereas the mean of the sample is equal to 11.8. I'm estimating from the sample statistics over here related that the population parameter would be equal to what? So that is basically what? That is the estimation itself. So statistical inferences is a branch of statistics. It's a branch of statistics concerned with using the probability. So we basically use the probability concepts over here so as to deal that what different components would be lying of the population would be lying as per the estimates which have been made by using the sample statistics. Okay, so it's of two types. First of all, it is a point estimate, and the second one, it is a interval estimate. So in the case of the point estimate, it's a simple number. It's a single number that we just have an estimate that is used for estimating the value. As I just told you that in the case of the 12th class result, the result would be 95%. So it's a single number. Even if the result is 94.7%, we will be saying that our estimate was wrong. That is basically related to what? That is related to the point estimate. So point estimate is what? Point estimate is a single number that is used to estimate an unknown population parameter. We want to estimate what? We want to estimate related to the population parameter using the sample statistics, sample statistics, and in that case particularly we use only single value, and further if it is wrong, it is wrong. So it may be either wrong or right. Okay, it is not the case that it will be lying in between. So if it is 94, even if it is 94.7, we'll be saying that our estimation was wrong. Okay, so point estimator would be much more helpful if it is accompanied by the estimate of the error. That may be involved. If we say that there can be an estimation error of about 0.3%, in that case we will be saying that this estimation was right. If we say that this estimation that we have basically come across, that is equal to 95%, if there can be error of 0.5% or 0.3%, in that particular case we'll be saying that our estimation was right. So it would be much more helpful or useful if it is accompanied by the estimate of error itself. Is that clear? Next, it is related to interval estimate. So related to interval estimate also, I just told you that if we are having a proper interval related to, so if we say that the result of the +2 class would be 93% to 97%. So it's a window we are having over here. So it's a window we are having over here that we estimated from the sample statistics related to the population parameters, and it is indicating in two ways that our range would be that much and this particular ratio can basically fall, the population parameter can basically fall under this particular window over here. Okay, so an interval estimate is a range of values used to estimate a population parameter. It indicates in two ways. It is indicated in two ways: by extent of its range and the possibility. Also, it indicates the range, and further also it indicates the possibility of the true population parameters lying with this particular range itself. So if I'll be saying that 95% of the, if I say that the 95% of the population is lying between this particular range itself, that would be related to what? That would be related to the factor of the possibility. That would be related to the factor of the possibility related to it. Okay, so that is related to what? That is related to the interval estimate. Further, it is related to estimator. So sample statistics that is used to estimate a population parameter is called what? It is called estimator. It can be in the form of the mean of the sample, or it can be the standard deviation or standard error of the sample itself. The sample mean can be used as an estimator of the population. The sample mean, as I told you, it can be used an estimator. Also, the standard deviation or standard error can be used an estimator of the sample of the sample statistics itself, so as to estimate the population parameter. And sample proportion can be used as estimator of the population proportion. So if I'm having a sample over here, and if I say that 42% of the literate sample population, literate entities in the sample itself, those are unemployed. Okay, try to understand this particular concept. So it's related to the sample over here. And further, if I say 42% of the entities in the sample itself, those are literate but unemployed. That's basically related to what? I'm just considering 42% of the people out of the sample over here. Let us take the case that the entities in the sample are 100. So in that particular case, we'll be saying what? We'll be saying a particular proportion is over there. And further, from this particular proportion, I want to estimate the population proportion. Okay, so that is related to what? Estimator can be the mean itself, it can be the standard deviation, or it can be the sample proportion that can be used as an estimator of the population proportion itself. Okay, now let's move further. It's related to that criteria for a good estimator. Criteria first for the good estimator, that the characteristics of the good estimator. First of all, it must be unbiased. So it refers to the fact that mean is an unbiased estimator of a population means, because the mean of the sampling distribution of the sample mean taken from the sample population is equal to the population mean itself. So it must be unbiased in a way that the mean must be equal to the mean of the population itself. So we can see that the statistical is unbiased estimator if on average it tends to assume values that are above the population parameter be estimated as frequently. So whatsoever the values those were basically estimated, those are basically tend to be in the same way. If we're saying those are increasing, in that case the population parameter values are also increasing. So those must be basically must be in the same manner itself. That is said to be what? That is said to be if the estimator is biased or unbiased. If the values are not moving in the same manner, in that case it is said to be unbiased. Otherwise, if it is moving in the same manner, it is said to be what? It is said to be biased itself. Okay. Then it is related to the efficiency. So it refers to the size of the standard error of the statistics. If I'm having the two estimators, let us take the case that I'm having the two estimators from the different samples. It is a sigma x1 bar and sigma x2 bar. In that particular case, we are talking about what? We are talking about the standard deviation. Standard deviation is related to what? Standard deviation is related to dispersion from the population mean. It is related to the dispersion from the population mean itself. So what would be more beneficial? If I'm having the standard deviation is equal to 14 or standard deviation equal to 8 itself, which one would be more helpful? Definitely where I'm having the lesser standard error, that would be much more helpful and that would be much more efficient, because in that particular way I'm having lesser errors when I compare the sample to the population itself. Okay, so that's related to what? That's related to the efficiency. Next, it is related to the consistency. That is the same thing that we have already learned. That is related to the, it must be consistent in a manner that if the sample size increases, if the sample size increases, in that case it almost certain that the value of the statistics come very close to that of the value of the proportion parameter itself. So let us take the case that we are having the x bar is equal to, or we say we are having the value of the sigma x bar, we are having the value of the sigma x bar, sigma x over here, not sigma x bar, it's the sigma x over here, the value equal to 12 over here. Okay, and previously the sample size small n is equal to 100 out of 1 lakh. Out of 1 lakh entities over here, we are having the sample size equal to 100. And when we increase the sample size to 10,000 over here, when we increase the sample size to 10,000 over here, in that particular case, our standard deviation must be lowered down. And further, if it is increased to 90,000, in that case, it must be becoming very much equal to that of the, it will be tending to 0. It will be tending to 0 itself. Okay, so that is said to be what? That is said to be consistency. Because standard error over here means what? That we are having a very lesser fluctuations as we compare the sample to that of the population itself. Okay, so if we are considering the mean, let us take the case that the x bar was equal to 13 and mu was equal to let us take the case it's equal to 9. So when we will be increasing the sample number, the sample statistic, it will be basically approaching and it will be becoming very close equal to the population parameter over here. It will be becoming very close to the population parameter over here. That is related to what? That is related to the consistency. Then it is related to sufficiency. That our estimator itself it must be sufficient enough that we are basically able to extract the most of the information out of it, that any other estimator is not able to extract that much information. So that is the beauty of the statistics now, because from a very small chunk of the entities we want to know all about the population itself, we want to infer all about the population. So our estimator must be in such a manner that we are able to extract most of the information out of it, and none other estimator can be used in that particular manner. So that is related to sufficiency. So that is related to the sufficiency itself. So these are related to what? This is related to the characteristics, we can say, of the criteria for selecting a good estimator over here. Further, it is related to the point estimates. So over here we are provided with the different sample entities. These are the different sample entities, 97, 99 and so on over here. So these are related to the 16 entities we are having. And further, the estimator over here, if we consider the mean as an estimator, in that particular case, it will be equal to what? It would be the sum divided by number if we just calculated the mean over here. And further, not related to the estimator over here, first of all, we just calculated the mean for the different entities in the sample. So it's equal to sum of the numbers, that is 97, 99 and all, and further that comes out to be 1617 divided by the number of the entities, that is equal to 16, that comes out to be 101.0625. Further, we just calculated for the different entities over here. We calculated, we just in the first column we have written x, in the second column we are having the x square, in the third column we are having the x bar, in the fourth column over here we are having the x minus x bar, and further in this particular term we are having the x minus x bar square. Okay, so this is related to what? That we want to calculate the standard deviation. If we want to calculate the standard deviation, what is the formula? The formula is equal to x minus x bar whole square summation of that divided by n and under root of the same. That is a formula related to what? That is related to the standard deviation over here. But in this case, particular formula itself, there is a biasness. That is why we basically in the denominator we replacing the term n by the n minus 1 over here. We'll be replacing the term n by the n minus 1 over here so as to remove the biasness. Over there. Okay. So this is the formula that we'll be using. So over here it is related to what? It is related to variance. So over here variance is equal to what? Variance is equal to what? It is the square of the standard deviation. So we can write the s square is equal to this particular term, and further if we write the standard deviation it would be under root of the same, and further it will be n minus 1 so as to, there was some biasness, so as to remove that biasness we'll be using this particular formula so as for the point estimate. So I'll be just letting you know that where we'll be using, because most of the questions that we'll be solving, it will be related to only and only the interval estimate that we'll be considering. Okay, so it's a theoretical part only that you need to consider. Further, the point estimate of the population proportion. So I just told you related that if you look at the proportion of the units that are related to the population itself, that is denoted by P itself. that is denoted by the P itself. If we look at the proportion, as the same case as just guided you, that we are having the sample of 100 entities over here, and further the 42% of the entities are literate unemployed persons. It is related to 42% of the entities in the sample itself. These are literate unemployed persons. In that particular case, 42% is represented what? It is the proportion of the units in the sample itself that will be represented by P bar. It will be represented by P bar. And further, when we are basically talking about the proportion of the entities in the population itself, it is basically represented by P itself. It is represented by P itself. So P bar can be used an estimator. As I already told you that the sample proportion can be used so as to estimate the population proportion. So as to estimate the population proportion. So that is related to this particular thing, that is related to point estimate of the population proportion. Further, it is related to the interval estimate. It is related to the interval estimate, and it's quite important related to the interval estimate. It's quite important related to the interval estimate. So we have already gone through the concepts, because you have already covered that's a particular concept, but definitely you just need to look it into further. So it's related to the standard error of the mean of the infinite population. So we have already covered related to where we'll be using the population multiplier or where we will not be using the population multiplier. I just told you that if the population is infinite population, and further if the population is finite population but with replacement, in that case particularly sigma x bar is equal to what? It is equal to the sigma divided by under root of n. It is equal to the sigma divided by the under root of n. That is related to this particular formula. Okay, and also I told you that the population, if it is a finite population, in that case it will be multiplied by the finite population multiplier. It will be multiplied by the finite population multiplier. And further, how we can just go for the, how we can just calculate the interval, how we can just calculate the interval, that will be considering. So over here we are having the graphical plot related to the related to the normal distribution. Related to the normal distribution over here. What do you mean by normal distribution? Where it is the curve is symmetric about the mean. Where the curve is symmetric about the mean. And whensoever we are talking about the infinite population, the samples so taken out of the population, it will always be tending to what? It will always be tending to the normal population itself when the sample size increases. When the sample size increases, that is related to the central theorem itself. What does the central theorem indicates? It indicates that if the sample size increases, the graph of the sample, would be basically, it will be tending to the normal itself. It will be tending to normal itself, whether the population graph was normal or not. Okay, so that was the related to central theorem. Further, let us consider the theoretical part related to it, and further it's quite important, so kindly pay attention to it. So probability is 0.955 will be within plus minus 2 times of the standard error of the population mean. Will be plus minus 2 times of the standard error of the population mean. What does it indicate? What does it indicate over here? So it's quite simple. So as to understand this, let me tell you that how does it works actually. So let us take the case if we are having the sigma x bar is equal to 2. Let us take the case we are having the value of sigma x bar equal to 2, and further let us consider that we are having the mean value of the sample is equal to, that is we are talking about the x bar over here. So if we are saying that x bar is equal to 95, in that particular case the interval would be equal to, with the, if we say with the 68.3% of the probability, if we are talking about that the 68.3% of the values of the population would be falling under the mean of this particular sample itself, in that particular case it will be 95 plus minus sigma x bar. So now you must be confused related to what it is. Let me just explain it further. So we are just talking about over here a population we are having, and out of this population we selected a sample, and further we calculated the mean for this particular sample, that comes out to be 95. Further we just did calculated the calculated the standard error for the sample statistic itself. We just calculated the standard error for the sample statistic itself. So that is related to it. So if we want to basically, if we are considering that the 68.3% of the population, 68.3% of the population will be falling under the mean so calculated by the sample itself, in that particular case the range would be equal to the mean plus minus sigma x bar over here. So over here we just assume the sigma x bar to be 2, so it will be 95 plus minus 2, that would be the range. So it will be equal to from 93 to 97, so that would be the range related to the 68.3% of the probability, that 68.3% of the population would be lying between this particular range over here. It will be lying over here in this particular range. And further, if we want to calculate the probability at 95.5% confidence level, at 95%, 5 of the 95.5% of the confidence level, this is said to be what? This is said to be confidence level. So 68.3% over here is a CL, that is a confidence level over here, and this is the UCL, that is the upper confidence level limit, and further 93 is a lower confidence level limit. Okay, is that clear? So it is a confidence level limit. If it is to be, basically we want to have an interval with 68.3% of the confidence. If we want to calculate the interval with 68.3% of the probability, in that case it will be equal to the mean plus minus the 1 time of the sigma x bar. And if you want to calculate at 95.5% of the probability, okay, that the terms of the population would be lying under the estimated interval itself, in that case it will be x bar minus plus minus 2 times of the sigma x bar. 2 times of the sigma x bar. In that particular case, we will be multiplying it with 2. Okay. So what would be the new range? It will be equal to, we just considered the x bar is equal to 95 plus minus 2 sigma x bar, that is equal to 4. That is equal to 4. So the range would be equal to 91 to 99. So that would be the range where the most of the terms, that is a 95.5% of the terms would be falling between this particular interval. Those would be falling under this particular interval. So that would be related to it. Is that particular part clear over here? Because it's quite important so as to understand it. It's quite important so as to understand it. Okay. So it was first of all related to that we are having the statistical data related to the sample, and further we just calculated the standard error, because in the case of the infinite population and further the finite population with the replacement itself, we can use the term related to how can we calculate the standard error. The standard error can be calculated sigma x bar is equal to sigma divided by the under root n. This particular information we have already understood in the previous lecture itself, that is already conveyed by me to you. Okay. And further in that particular case, this would be the thing that if you want to calculate the interval at a 68.3% of the probability, in that case plus minus 1 times of the standard error is to be used, and further in the case of 95.5% of the probability, it would be 2 times of the standard error that is to be added up or reduced from the sample statistic itself. Is that clear? So that is how we can do estimate. And further, this is not only related to 95.5% or 68.3% of the probability. There can be the much more that can be calculated, and for that particular purpose we will be using the Z table. In the previous lecture also we used the Z table, and in this particular case also the Z table can be used. But let me tell you, in this particular case the Z table to be used in opposite manner, where we'll be looking at the different values, and further we will be calculating the values from that particular manner to our calculations itself. Is that clear? Because I just told you in the previous lecture itself, if we just look over the graph over here, we say it is normally distributed. It means what? That this is having the 0.5% of the probability. Over here we are having the 0.5% of the probability, this particular side, and on this particular side also we are having the probability of 0.5%. That is what we considered in the previous lecture itself. And if we look at the Z table value over here, in this case particularly also it would be the same way. It would be the same way also in this particular case. So we'll be considering that particular scenario also using the Z table, that how we can look into the values for the different probabilities if we want to look into. So that we will be covering with the questions itself. Okay. So now let's have a look that there is a direct relationship between the confidence level and the confidence interval. There is a direct relationship exists between the confidence level and the confidence interval itself. That's quite simple itself. What does it indicate? If you're having the confidence level, equal to 99.9%, if we say we are having the confidence level of 99.9%, in that case particularly, the range would be much wider. It was quite visible from the 68.3 and 95.5% also. In case of 68.3 to 68.3% over here, the range was ranging from 93 to 97. Whereas in the confidence level for the 95.5%, it was ranging from 91 to 99. If you will be looking beyond 95.5% of the confidence level, definitely the range would be widened up. So it indicates what? It indicates that there is a direct relationship. When the value of the confidence level is increasing, definitely definitely our confidence interval is also widened up. That is also increasing over there. Okay. Further, as I already told you that it is related to the interval estimates on large samples. So in case of the large samples where n is greater than 30, where the sample size is said to be greater than 30, in that case we can do apply what? We can do apply the central limit theorem. So in that case we can do apply the central limit theorem. So central limit theorem do indicates what? The central limit theorem do indicates that there will be no differences whether related to or unrelated from the population graph itself. If the sample size increases, the sample distribution will basically turns to be normal itself. Okay, it turns to be normal itself. So the population size is large and further the sample taken is greater than 30, then central limit theorem allows to use the normal distribution. It allows to use the normal distribution as sampling distribution tends to normal even if the population is not normal. Are you getting my point? So even if this graph is population distribution, it is somewhat like that. It is not normal. It is not symmetric around the mean itself. It is not symmetric among the mean itself. But when it is related to large population and further n is greater than 30, in that particular case, the sample distribution would be normal itself. It will be tending to normal itself. Okay, so in that case, we can also use the same criteria that is related to sigma x bar is equal to sigma under root of n. So in that case also we can calculate the standard error by using the same formula over here. And further, when the population standard deviation is unknown, when you are basically known not about the population standard deviation, because if you want to calculate the standard deviation for the mean itself, standard deviation of the sample itself, not the mean, if you want to calculate the standard deviation of the sample itself, in that case the formula turns out to be standard deviation of the population divided by the under root of n. N is equal to what? N is equal to the number of entities in the sample itself. So if you do not have the value related to sigma over here, how we will be calculating it? So it's a simple formula related to it, that the standard deviation is equal to what? It is equal to x minus x bar and further the square of that and the summation of those and further divided by n minus 1. Why n minus 1? Because there was some biasness that we wanted to remove and that is why we replaced n by n minus 1. Is that clear? Is that particular part clear over here? It is related to when we want to calculate the interval. When the population of the standard deviation is not known. So central theorem, when we can basically use this, when the central theorem is applicable. And when we are having finite population. And then finite population multiplier must be used. And in case we are having finite population, in that case finite population multiplier must be used, that is equal to capital N minus n divided by capital N minus 1. So that is the formula that is to be used for this particular calculation. Is that particular part clear over here? We have already covered that related to it. So what are the different scenarios that we have covered? Let me tell you again, where the formula that is equal to sigma, because it's quite confusing. It would be quite confusing when we will be calculating it. So sigma x bar, sigma under root n. When this particular formula will be used? When first of all we are having the infinite population. When we are having the finite population but with replacement. When we are having large population. And further the sample size taken is greater than 30. In that particular case, this formula is to be used. And further, if it is finite population and further these criteria are not met, in that case you will be multiplying it with the population multiplier, that is capital N minus n divided by capital N minus 1. Is that clear? Is that particular part clear over here? So that would be related to when the standard error of the population is not known. Okay. So interval estimate of population proportion from large samples. Interval estimate of the proportion from large samples. When we are having the discrete values in the sample itself. In that case, we'll be using the binomial distribution. In case we are not having the continuous data and further we are having the discrete data, each and every data is not related to each other, we'll be using the binomial distribution in that case. And further, when it is related to estimate of the proportion. So in previous cases, we basically were calculating the estimator related to the statistical estimator. Okay. But in this case particularly, we are going to calculate for the We are going to calculate for the statistical proportion. We are basically considering it related to the statistical proportion. Okay, so particularly interval estimate of proportion from large sample itself. So binomial distribution will be used in that particular case, and you just need to remember few formula that is related to mu is equal to np. First of all, it is related to mu is equal to np, and further it is related to p is equal to or we can say total probability is equal to what? It is equal to 1. So we can say p plus q is equal to 1. So P is related to what? P is related to the success intervals and success events over here, and Q is related to what? Q is related to the failure events over there. Is that clear? So P is related to probability of the success events, and Q is related to the probability of the failure events. So in total that will be equal to 1, or we can simply say if P is known, we can calculate by 1 minus P over here. Q will be equal to 1 minus P. Okay. So in that particular case, mean would be equal to what? The mean of the population we are talking about, that mu is equal to NP, and further the standard deviation is equal to what? Standard deviation is equal to sigma is equal to NPQ under root of that. NPQ under root of that. N is number of total trials, the total number of events that we are having, and P is basically the probability of success. It is related to the probability of success, and Q is related to what? Q is related to probability of failure over here. So if we take a particular example over here, let us consider the same example where I just say you that I'm having a sample over here. And where I'm having 100 entities, and 42% of the entities in this population are literate but unemployed. And if I consider it as my success event, in that particular case, I'm known about that the 42% of the entities are basically not known. I can simply say that 0.42 would be the probability. 0.42 is the probability that these basically are what? This is related to the success event formula, that is the probability of success, that is equal to P. So I can simply say P is equal to 0.42, and what will be related to Q? Q will be equal to 1 minus 0.42. That would be the value of Q, and from there I can do calculate the standard deviation, I can do calculate the mean. So mean over in that particular case, that will be equal to mu is equal to NP, and further we'll be having the standard deviation is equal to NPQ under root of N. Okay, so that would be related to what? That is related to from the proportion from the from the large sample itself. That is applicable where we are having the large sample, and further in case we are dealing with what? We are dealing with the proportion. We need to get a proportion estimator from the sample so as to estimate the population proportion. Okay. So over here N should be large enough, and must be large enough that the multiplication of NP and further NQ must be at least 5. So N must be large enough. What is the criteria and where this particular method will be applied? What is the criteria and where this particular method will apply? Where the value of NP and NQ is at least 5. And further I just told you mu is equal to NP, and further sigma is equal to NPQ under root. That is the formula related to it. And further, to change the number of success to the number of proportion of successes, we will be dividing NP by N. We will be doing what? We will be dividing NP by N. So we can simply say mu would be equal to N, mu would be equal to P, and further the NPQ would be equal to PQ. That would be the simple formula that we can do calculate. So we need to do what? I just first of all did let you know related to the binomial distribution, we considered where the sample is large, So this is a theory that you need to focus upon. So if the sample is large, second, it is related to where I just need to have a sample proportion. There the binomial distribution is to be used. And further over here we are having the mu, that is a mean of the population related to NP, and further we are having the value of sigma is equal to NPQ under root, where P is the probability of success, Q is the probability of failure, and further P plus Q is equal to 1. And further what we considered, that if I want to convert, because over here we were considering related to, we are basically concerned related to the number of successes. And further, if we want to convert this number of successes into proportion of successes, we will be dividing NP by N over here. So in that case particularly, your mu would be equal to Now in that case particularly, mu would be equal to what? It will be equal to P simply. And further, sigma would be equal to what? It will be equal to, because it's under the square root, so it will be PQ. It will be PQ divided by N. Okay. So that would be the formula that you need to remember, or you simply remember this particular formula and just remember that we want to convert the number of successive into number of proportion, and further we'll be dividing the NP by N itself. Is that clear? Is that particular part clear over here? It's quite important so as to understand this particular thing, so as to get to the formulas over here, so as to get the formulas over here. Okay. Further, we'll be solving some of the questions based upon that, so that you could understand it well. Okay, so first question over here, it's related to that undergraduate is interested in purchasing a used TV. She randomly selected 125 advertisements. She randomly did what? She randomly selected 125 advertisements over here. So simply I can say N is over related to the size of sample. So N is equal to what? N is equal to 125. That is a small n over here. And found that average price of the TV in this sample was what? It was equal to 3250. So the average price is given of the sample is given to be what? It is given to be 3250. She selected 125 advertisements, and further the average price was 3250. So over here we are provided with the X bar over here, that is 3250. That is 3250. She knows that the standard deviation of the used TV is equal to what? Is 615 in the city. So in the city, it means what? It means the population itself. So the sigma over here is given to be what? It is given to be 615 in this particular case. So established an interval. Over here we are not provided the number of the samples, number of the entities in the population itself. So we'll be considering it as a very large population, or we can simply consider it infinite population. In both the cases, your formula, that is a sigma x bar, would be equal to sigma under root by n would be applicable. Okay, so you will be applying this particular formula over here. And for the the question is related to establish an interval of the average price of the TV, so that she can be 68.3% certain that the population mean lies between this interval. So what is the criteria? She wants to be 68.3% certain that 68.3% certain that the population mean is lying between the estimated value over here. That is the interval that we need to calculate. So what it would be? So over here sigma is equal to what? It is equal to 615, and is equal to what? And is equal to 125. That will be solving, and that's quite simple. So 125 under root. So 125 under root, that's equal to 11.18, and 615 divided by 11.18, that comes out to be 55. That's equal to 55.01, and further it's equal to what? It's equal to 68.3%. Now what was the mean over here? The mean was equal to, the mean of the sample was equal to 3250. So what would be the interval for 68.3% of the certainty? What is the formula? It is mean. Let me write it mathematically so that you could understand it well. So it will be equal to what? It will be equal to, for 68.3% of the certainty, or we can say 68.3% of the confidence level, not PL, it is CL, confidence level of 68.3. So it will be what? It will be X bar, and for the plus minus sigma X bar. So that is the formula related to it, and this is what you need to solve. So we are already having all the values, so it will be 3250 plus minus the 55.01, or we can simply say 55 over here. So it will be equal to 3250, or mean was given to be what? Mean is given to be what? Mean is 3250 now. So 3250 minus 55, that is equal to 3195, and further the second factor would be 3250 again plus 55, that is equal to 3305. Okay, so that would be the interval, that we are concerned about. That is the interval that we are concerned about. Is that clear? Further, the second part, it says establish an interval of the average price of the TV so that she can be 95.5% certain. For 95.5% certainty, what was the confidence level? For the 95.5% of the confidence level limit, what was the basic formula related to it? It was related to X bar plus minus 2 times of the sigma X bar. 2 times of the sigma X bar. So it will be related to what? What is the value of sigma X bar? It is equal to 55. So it will be equal to what? It will be 3250 plus minus 110. Plus minus 110, and that would be related to it. So it will be 3250 minus 110. And that is equal to 3140, and that is ranging towards 3250 plus 110, that is equal to 3360. So that is a range. That is a range that we are concerned about. Okay, so that would be related to this particular question. Can you please do confirm at the earliest so that we could proceed further? Can you please do confirm at the earliest so that we could proceed further? Okay, very well. Next question, it says, from a population known to have a standard deviation of 1.4. So the standard deviation of the population is given directly over here. That is, sigma is given to be 1.4. And for the sample of 60 individuals, so it means small n value is given to be 60 over here. Further is taken, the mean of the sample is found to be 2. See, mean of the sample, that is x bar, is given to be 2 over here. And further, find the standard error of the sample mean. So over here, just look at the population. From a population known to have a standard deviation, but the population number is not given, so we'll be considering it to be a large population. So we can say in that particular case the central theorem limit will be applicable. And further we can say over here what, that the sigma x bar is equal to what, sigma x bar is equal to sigma divided by under root n. So that's quite simple. Now you must have all understood that what is the procedure so as to calculate. So it will be 60 under root. So it will be under root 60. So that would be related to it. So it will be 1.4 divided by under root 60. So it will be equal to 60 under root. So 7.7459. That is equal to 0.181, or we can simply say 0.18. So that is related to this particular, that is related to what? That is related to standard error of the sample mean. That is related to the standard error of the sample mean. Okay, that is 0.18. That is equal to 0.18. Okay. And further, what does it say? Establish interval around the sample mean using one standard error of the mean. That is what we need to calculate. It is related to, first of all, around what? Around the sample mean itself. It is given to be what? It is given to be 2. So x bar is given to be 2. And further, we need to calculate an interval around it. And using one standard error of the mean, that is equal to sigma x bar. So it will be equal to plus minus 0.18. So it will be equal to 2 minus 0.18. That is equal to 1.82 and ranging towards 2.18. So that would be the interval that we need to calculate over here. So that is the interval that we need to calculate over here. Okay. Now further, let's move to the next question. Let's move to the next question. It says, for a population with known standard deviation of 1.65. So standard deviation is given over here. Standard deviation, that is a sigma over here. It is given to be 1.65. Further, a sample size is given to be 32. Further, resulted in 34.8 of the estimate of the mean. Resulted in as 4.8 as an estimate of the mean. So it basically related to what? It is related to the mean is given. Relatedly, we are provided with the what? We are provided with the mean over here. So first of all, we need to find the standard error of the mean. So kindly please do answer at the earliest. What would be the standard error of the mean over here? So what would be the standard error of the mean? So over here, already we know sigma x bar is equal to sigma, that is 1.65 divided by under root of what? Under root of 32. So it will be equal to what? 32 under root, that is equal to 5.65. 5.65 over here. So it will be 1.65 divided by 5.65. Which is equal to 0.29. 0.29 over here. Okay. 0.29 over here. And what is the mean that is given over here? That is x bar is given to be 34.8. And further we are concerned about compute the interval. Estimate that should include the population mean 99% of the times. So we want to have an interval with 99% of the confidence level. Do we know the different value of the z values over here related to 99%? That is not given to us or not provided to us. In that case, how we will be how we will be calculating the same? How we will be calculating the same? So that's quite possible. Let me tell you. So we'll be using the z table again. So we'll be using the z table again over here. So let me tell you how we can do that. Kindly please wait for a minute. Kindly wait for a minute so that Okay. So we are having the Z table over here with us. Let me just paste the value. Okay. So over here we are having the Z table. It must be visible quite over here. So it's related to 99.99%. It's related to 99.7%, not 99.99. It's related to 99.7%. So in decimal, this value would be equal to what? It will be equal to 0.997%, or we can say simply 0.997. So I just told you that if we are having the normal distribution, in that case the distribution is normal or symmetric. So we'll be dividing it by 2. So 0.997 is equal to what? 0.997 is equal to divided by 2. So it will be equal to 0.4985. It's equal to 0.4985. So we'll be looking the value of the 0.4985 over here. So it comes out to be over here. So it comes out to be over here. So it's 2.96. 2.96. It comes out to be 2.96 or 97. It comes out to be 2.96. Okay, so the value comes out to be 2.96. It means what? So we just need to ascertain the interval now. So we'll be doing what? So over here we are provided with the x bar that is equal to 34.8 plus minus 2.96 times of the interval value, that is 0.29. So that is how we will be calculating the same over here. So this is how we will be calculating the same over here. Are you getting this particular point over here? So kindly please do confirm at the earliest. So it is a 0.29, the value we are having over here, and further we'll be multiplying it with the same. So that is the value we are concerned about. So that is the value we are concerned about, and we will be solving it. Okay. Are you getting this particular point over here? Kindly please do confirm if this particular point is clear. So first we did what? We did calculate the sigma x bar, that is the standard error of the sample itself. And further we are having the x bar over here itself. And further we were looking for the 99.7% of the confidence level as given in the question itself. Let me show you again. It is a 99% of the confidence level interval that we need to compute. And that particular purpose, we just looked at the we just had the decimal value of 99.7%, that is 0.997. And further we had the half of it, that is equal to 4.985, 0.4985. And further we just looked at the table and just got the value related to it. And further here we are having the value that is 2.96 over here, that is equal to 2.96 over here. And further this is how we solve the value. Okay. So here is a question related why we haven't used the multiplier, because there was related to large population. And as I already told you that the number of items, if it is greater than 30, in that case we'll be using what? We'll be using the central theorem. The central limit theorem would be applicable in that particular case if the n is greater than 30 and it's related to a large sample. Is that particular part clear over here? And further it's said we denote the standard deviation of the sample as sigma x bar. We denote so this question must be clear. So over here if we are having a query related, we denote the standard deviation of the sample as a sigma x bar. So we relate it with sigma x bar related to the sample itself. And further the standard error also the same. There is no difference between those. Standard error and standard deviation are having no difference in between. There is no difference between in there. Okay. Further, let's move further to the next question. It says, a company manager wants to inform the potential renters about how much electricity they can expect to use during each month. Okay. She randomly selects 61 residents. She randomly selected 61 candidates. It means what? N is equal to what? N is equal to 61 over here. And discovers their average electricity usage in August to be 984 kilowatt hour. So what is the average electricity that used? That is x bar is given to be what? X bar is given to be 984. It is given to be 984. And further, she believes the variance in usage is about 131 kilowatt hour. Over here, we are not provided about by the standard deviation is not given. We are provided with variance. That is a sigma square value. Sigma square value is given to be what? It is given to be 131. It is given to be 131. And we want to establish an interval for estimating the average August electricity usage so that she can be 68.3% certain about it. Okay. So in that particular case, we'll be doing what? First of all, we will be calculating the value of the sigma x bar. We will be calculating the value of the sigma x bar, that is equal to sigma divided by under root of n. Now over here, we will be calculating the value of the sigma over here, that is related to standard deviation. So standard deviation is equal to what? It is equal to under root of 131. So that would be 131 under root, that is equal to 11.45. That is equal to 11.45 value. And over here, the value would be equal to 11.45 divided by under root of n, that is equal to 61. So 61 under root, that's equal to 7.81. That's equal to 7.81. So 11.45 divided by 7.81. So that comes out to be 1.47. So over here we are having the value of sigma x bar equal to 1.47. Okay. And further we need to ascertain the interval. So that will be equal to x bar and plus minus the 68.3% certainty means what? Sigma x bar over here. So x bar is given to be what? It is given to be 984 plus minus 1.47. So that would be the interval. So that would be the interval over here. So 984 minus or plus 1.47 first of all. So it is equal to 985.47, and further 984 minus 1.47, that's equal to 982.53. So that is the interval related to this with the 68.3% certainty. So that would be the answer related to it. So that would be the answer related to it. You must be certain about it, what data is given to you and what particular terms are to be used. Is that clear? Okay. Now let's move to the next question. It says a social psychologist surveyed 150 top graduate students and found that 42% of them were unable to add the fractions correctly. So social psychologists surveyed 150 top graduates. So it means what? The sample size is given to be 150 over here. And further found that 42% of them were unable to add the fractions properly. 42% of them were unable to add the fractions properly. What does it indicate? So we are provided with 150 over here, that is equal to n. And further 42% is related to what? It is related to the proportion. Related to proportion of what? Related to proportion of the sample itself. So it can be denoted with p bar. So it can be denoted with p bar over here. Na? I just told you that we can denote it with p bar over here. So further it is given, estimate the standard error of the population. Estimate the standard error of the population. Now it's related to proportion over here. And further I just told you that the formula related to the binomial distribution were related to, there were the two formulas that you need to remember, that is equal to mu and further related to sigma. So sigma was related to NPQ. Further I told you that was related to number of successes. If you want to convert them into the number of proportions, you need to divide the NP by N. So in that particular case, the mu became equal to P and further the sigma became equal to PQ and divided by N under root. So that would be the formula that we will be using. So it would be quite simple over here. And further you just need to look at the proportion over here. In that particular case, you need to have an estimate from this particular purpose. So we can say 42% of 150. It would be equal to what? 42% of the 150. So 150 into 42%, that comes out to be equal, 150 into 42%, that comes out to be equal to 63. So over here we are having the success event equal to 63, we can say. We are having the success event equal to 63, or we can simply say the success, because it's a proportion, it will be a probability. Na? So 63 out of 150, what would be the probability? 63 out of 150, that is equal to 0.42. So that is a probability. So what is the success probability? That is equal to P. So P is equal to what? P is equal to 0.42. P is equal to 0.42 over here. And further, if I want to get the value of Q, what would be the value of Q? It's quite simple, because total probability equal to 1 na. So P plus Q is equal to 1. So it is equal to 1 minus P. So 1 minus P, it means what? 1 minus 0.42, that is equal to 0.58. So Q is equal to 0.58. And from that particular formula that I can use and further get all the values over here. So it will be equal to what? So it is quite simple over here. So as to solve this particular formula, so it is equal to P is given to be, we just had the value of 0.42 multiplied by the Q value, that is comes out to be 0.58, divided by the number of terms, that is equal to 150 over here. And from here we can get the value of the sigma P by bar over here, sigma P bar over here, the value that we can calculate. This was just for reference purposes. Otherwise we are concerned about over here related to sample, so it will be related to sigma P bar over here, sigma P bar over here. So what will be the value related to the estimate? So it will be, first of all, we want to calculate the standard error, standard error of the population. So standard error over here in this particular case would be equal to 0.42 multiplied by 0.58 and further divided by 150 over here, and further we want to have an under root of this, so it will be equal to 0.4029, 0.040. So I'm just writing it over here on the top so that you just do not get confused. So it is equal to sigma P bar over here, it is equal to 0.040. So that is the value over here. So that is a value over here. And further we want to get a idea related to it. We want to get a idea related to the construct a 99% confidence interval. We need to construct what? We need to construct a 99% of the confidence level interval for the true proportion of the graduate who cannot correctly add fractions. So what would be the range? The range would be equal to, because we are having the proportion over here equal to 0.42 now as we calculated. So what was equal to? First of all, 42% of the 150, and for the 42 whatsoever the term that you got, that is equal to 150 into 42%, that is equal to 63 divided by 150, that is equal to 0.42. So our interval would be 0.42, and further plus minus the confidence level value that we will be having, and further multiplied by 0.040. Now if we look at the value over here, that is 99% value now. So 99% value we convert into decimal part, it is equal to 0.99, and further 0.99 divided by 2 itself is equal to 0.495. That is the value we are concerned about. It is equal to 0.495 value that we are concerned about over here, and we'll be looking at the value over here. So we will be looking at the Z value over here. So let's go to the Z table over here. So it's a value of 0.495. It is a value of the 0.495 we are concerned about. So it comes out to be over here. So we can say 0.4949. Let me check the value. If it's here, it's yeah, this one would be the value. So this one would be the value. So it's equal to what? It's equal to 2.58. It will be equal to 2.58 over here. So we will be looking at the upper factor. So it will be equal to 2.58 over here. So this value is equal to 2.58. Okay, so it will be 2.58 times of the 0.040. So we can easily solve this question over here now. So it is 2.58 multiplied by 0.04, that's equal to 0.10. So this interval there will be, so 0.42 plus minus 0.1032, and further 0.42 plus 0.1032, that is equal to 0.5232, and further 0.42 minus 0.1032, that is equal to 0.3168. So that is a range. So that is a range, that is 0.31682 to 0.5232. 3.31682 to 0.5232. So that would be the answer related to this particular question. Is that particular part clear over here? So that is how we will be solving it. This is how we will be solving it. So first of all, we'll be doing what? So first of all, in this particular question, we'll be doing what? So first of all, we did what? We just had the proportion over here, and from the proportion over here, we calculated the value of the P bar over here, and further we calculated the value of the sigma P bar over here, and further we just simply subtracted the value from it, and that was the answer, over here. So this would be all related to this particular session.